Hey, before I start messing with your brain with a bunch of questions, let's try something really simple. Pinch your arm or lightly touch the surface of the table in front of you. Then pause for a second and ask yourself who or what just felt that. Because here's the thing. If I ask physicists about atoms, electrons, electromagnetic fields, or gravity, they'll talk your ear off. We have equations for everything from planetary orbits to the probability of an electron jumping energy levels. But there isn't a single equation. Trust me, I've looked. That explains where the one who's feeling that pinch is located among all those mindless particles. I, someone who's spent a lifetime with quantum physics and messy diagrams, have to admit that this is the one mystery I cannot solve with any tool physics has ever given me. Not because I'm too lazy to write more equations, but because this problem simply refuses to fit inside the framework of any kind of equation at all. And don't think this is some far-out philosophical thing. No, this is a very real, very serious limit of physical science. We can describe everything that happens in the brain, except the very feeling of hearing me say this right now. And that's where all the trouble begins. Now let me show you the thing that makes physicists like me tear our hair out. What philosophers call qualia, and what I prefer to call the stuff my equations refuse to describe. You see the color red, right? But photons aren't red. They're just electromagnetic ripples with different wavelengths. You hear a violin, but there's no music in the air, only pressure waves going up and down. Yet inside your head, those vibrations turn into a melody that gives you goosebumps. And think about the taste of chocolate, the sharp sting when you hit the edge of a table, or the smell of jasmine that makes you smile without thinking. Not a single one of those things appears in Maxwell's equations, Schrödinger's equation, or any diagram I've ever drawn. Physics can tell you the intensity of the photons, the frequency of the air vibrations, the energy level of the electrons, but it remains completely silent about the feeling of red, the feeling of hearing, the feeling of pain, the feeling of pleasure. Physics describes signals. It does not describe experience. And this is when we get hit with a gentle but very real shock. Everything you're feeling right now, the subjectivity, the private inner sensation that only you know, lies outside the scope of current physics. That is exactly what qualia are, not behavior, not information, but what it is like to experience it. And once you realize that, the next question slams into your forehead like a ping-pong ball. If atoms don't contain experience, then where does experience come from? Where is the universe hiding it? Or is there something current physics is not yet sharp enough to see? Now we're stepping into the territory people call the hard problem of consciousness. And trust me, it earns that name. And this is the moment I have to tell you something. Many scientists hate to hear what people call the hard problem of consciousness isn't actually hard in the ordinary sense. It's absurd. Hard means you haven't solved it yet, but you still know what kind of math to use, which direction to attack from. Here, we don't just lack the solution. We don't even know which academic discipline the question belongs to anymore. Philosophy, physics, neuroscience, no one wants to claim it. To show you how absurd this is, look at what are called the easy problems. They sound impressive, but they're really just technical problems. How does the brain recognize faces, like Hubel and Wiesel's work in 1959? How does it process sound, integrate signals from the senses, control behavior, make decisions? All of those. I'm not saying they're easy, but they belong to normal science. You measure, you build models, you find neural correlations. When you show someone a face, the fusiform face area lights up. When they hear a loud noise, the amygdala activates. When they move their limbs, the motor cortex fires like fireworks. Those are things you can observe with fMRI, EEG, MEG, and the history of science has proven that the more data we collect, the more mysteries we solve. But the hard problem, the concept named by David Chalmers in 1995, doesn't ask which part lights up when we see red. It asks, why is there a red experience in the first place? Why isn't it just mindless electrical currents running through 86 billion neurons? Why is there someone in there feeling anything at all? And you know what makes me want to scratch my head. You could understand the entire structure of the brain, every synapse, every ion channel, every neurotransmitter molecule, like glutamate or dopamine, and you still wouldn't understand why red is experienced as red. That's what's bizarre. We have Maxwell's equations describing photons, Schrödinger's describing electrons, Dirac's describing spin, but there is no equation in physics that turns electron red, or proton pain, or electromagnetic field joy. Not a single line of mathematics in the entire history of physics, from Newton in 1687 to quantum mechanics in 1926 to the Standard Model of Particles in 1970, contains even a hint of subjective experience. All of physics describes processes, interactions, signal transmission, but experience is not a signal. Experience is the quality of the signal when it is felt by someone. Physics describes the world from the outside. Consciousness only exists from the inside. These two languages do not intersect. I used to joke with students at Caltech that if you take apart a radio, you'll find transistors and wires, but you won't find Elvis Presley inside. Consciousness is the same. You can observe neurons firing at 40 hertz gamma rhythm, but you won't find red at 700 nanometers or coffee smell anywhere. Now think about the biggest paradox, understanding the structure of the brain, understanding consciousness. The brain can be divided into hundreds of regions: occipital lobe processes, vision; temporal lobe processes, sound; parietal lobe processes, touch; hippocampus creates memories. But your experience is not fragmented like that. When you look at an apple, you don't see color here, shape there, motion somewhere else. You see one unified object. But the hard problem doesn't stop there. It hits you with a second punch. Even if we understand how the brain binds information together, we still don't understand why that binding is experienced at all. A computer can also bind information. An artificial neural network can recognize faces. But do they experience anything? If not, then why do we? And if they do, then what physics explains that? I know this sounds very weird, but the truth is, the hard problem isn't just hard. It lies outside the reference frame of current physics. Physics was built to describe observable events, but experience is something that cannot be observed from the outside. It can only be experienced from the inside. How can an outward-facing science describe an inward-facing phenomenon? We're like trying to measure the color blue with a thermometer. The tool doesn't fit the question. And to understand why physics, with all its beauty, fails completely when it touches consciousness, we have to start from what seems the most obvious thing: perception. So let's begin with what seems the simplest thing. You open your eyes and see the world. It sounds obvious, but if you really follow the process, step by step under the lens of physics, you'll realize that nothing resembling experience happens anywhere in the entire chain. When an apple reflects light, it doesn't send red to you. It just throws photons of about 700 nanometers wavelength toward your eye. Those are just electromagnetic oscillations, not red, not warm, not sweet. They are mindless ripples described by Maxwell in 1865, and never once mentioning your feelings. Those photons hit the retina. a biological sensor with about 126 million receptors, 120 million rods for low light, and 6 million cones that distinguish colors. But even the cones don't know what red means. They only change membrane potential according to how many photons they catch. So right from the very first step, experience is absent. From the retina, electrical signals travel along the optic nerve at about 100 meters per second and pass through the lateral geniculate nucleus, the brain's big relay station. The LGN routes the signals like a giant postal system and sends them to the primary visual cortex V1. And their surprise, still no red. V1 is just the place where neurons fire, according to preferred patterns, straight lines, tilted lines, edges. Tens of thousands of neurons, discovered by Hubel and Wiesel in the 1950s, proved that vision begins with geometric analysis, not experience. From V1, the information spreads to V2, V3, V4, where V4 is especially sensitive to color. But don't get excited yet. Even the color-specialized area has no red happening. Just changes in voltage, neurotransmitter release, sodium and potassium ion shifts. All of it completely physical and completely non-experiential. I often tell Caltech students that the visual process is like sending a letter through a dozen relay stations. Each station checks the envelope, stamps it, sorts it, forwards it. But the funny and haunting thing is none of the stations contains the content of the letter. No neuron contains red. No spike knows it's carrying a sensation. No molecule understands that you're looking at an apple. So where is the experience? Who is looking? Who is feeling? Physics says, not me. If I had an infinite budget lab and enough time to live for centuries, I could track every neuron of yours with electrodes, every millisecond, collecting terabytes of data about neural network activity. I could simulate the entire photon retinas, spike occipital lobe process on a supercomputer. But in the end, all I would have is a stream of information, not experience, not red, not feeling. And this is the key point many people miss. At no step in the entire signal processing chain can physics point and say, aha, here it is. This is where the feeling appears. The whole process is just transmission, transformation, analysis, completely unlike what you're experiencing right now. As you look at the world, there is no equation that describes the strange leap from electron red sensation, from signal experience, from matter subjectivity. Physics not only doesn't explain that transition, it doesn't even have the language to refer to it. This leads us to a painful but true observation. Perception as described by physics is a signal processing machine, but perception as human experience is a vivid living world. These two do not match. And if perception, the most basic thing in consciousness, contains no experience in any physical description of it, then that signals a much larger truth. Consciousness is not located in the physical components of the system. It lies in the part that physics completely overlooks, the part entirely ignored by our equations. If you've started to feel uneasy because you can't find red anywhere in the whole photon, retina, visual cortex journey, then congratulations, you're beginning to feel the real helplessness of science when it touches qualia. And to see it even more clearly, let's put qualia, subjective experience, under the microscope of modern science. What's the first thing you see? Neurons, and lots more neurons. They fire electricity, release neurotransmitters, change membrane potentials, just like switches, flipping on and off non-stop. But no matter how closely you look, at 1 millisecond resolution or 10 microvolt precision, you never find what you're feeling right now. Neuron firing is an objective physical process. Experience is completely subjective. These two stand on opposite sides of an abyss that science doesn't yet know how to bridge. Imagine I have two brains. that are identical down to the millimeter. Every synapse perfectly copied. Call them brain A and brain B. Physically, they are exactly the same. Same number of neurons, same connectivity, same signal strengths. But would they have the same experience? Science cannot answer. No algorithm, no model, no formula guarantees that two physically identical systems will produce two identical subjective worlds. And that lands us with a classic problem. Physics describes structure, but experience is not structure. To see the paradox clearly, here's a fun example. You can describe a violin with hundreds of parameters: string length, wood thickness, string tension, vibration frequencies. You can draw 3D blueprints, analyze every resonance mode, even simulate molecular motion of the wood. But describing the violin, no matter how accurately, does not produce music. Description is not experience. Likewise, a physical description of the brain, even down to every sodium ion, does not produce the feeling of red, pain, joy, sadness, or any qualia. And this isn't just a matter of we don't understand enough yet. This is a problem inherent in the very nature of physical description. Look at neuron firing. Mathematically, it's just a voltage change from minus 70 MV to plus 30 MV and back. You can write the Hodgkin-Huxley equations describing this process from 1952 with such precision that computer simulations match real neurons perfectly. But those equations, no matter how beautiful, don't contain a single word about the pain when you stub your toe or the sweetness when you taste chocolate. They describe neuron activity, not experience. It's like describing the structure of a violin without describing the symphony. And this brings us to a chilling observation. All of modern neuroscience is only studying signals, not qualia. When someone sees red, area V4 lights up. When they hear music, the auditory cortex fires. When they feel emotion, the limbic system activates. But this is only correlation, not explanation. It's like saying, when the radio plays music, the light on the radio turns on. Fine, but the light turning on doesn't explain the music. A neuron firing doesn't explain the red experience. A brain region activating doesn't explain the feeling of pain. And even if you recorded all 100 trillion synapses, you'd still only have a map, not experience. Try this thought. I give you all the data of a Mozart piece, frequency of every note, amplitude of every beat, information about every instrument. You could reconstruct the complete sound spectrum, but you will never find the shiver down the spine that the music produces inside that data. No number contains beauty. No equation contains meaning. Similarly, no physical description contains qualia. And that is exactly why physics, no matter how powerful, still hits a wall when it reaches consciousness. Physics describes what can be measured, but qualia cannot be measured, only experienced. Physics describes motion, force, fields, but experience is not motion, not force, not field. It is the inside face of a process that physics only sees the outside face. Science can describe everything that happens in the brain, except what happens in experience. And this leads us to an uncomfortable conclusion. Experience cannot be compressed into any physical description. It does not belong to the language of electrons, protons, electromagnetic fields, or partial differential equations. It belongs to a level that current physics does not reach. But the mystery doesn't end there, because when the brain starts combining information from different regions, the gap between physics and experience grows even wider. And to see more clearly the biggest mistake we usually make when talking about the brain, I want to tell you a very everyday example. One I used with Caltech students when they thought understanding the brain's structure naturally meant understanding experience. I told them, try to explain a car. Everyone immediately got excited. Internal combustion engine, pistons, crankshaft, spark plugs, fuel-air mixture, explosion at 2,500 degrees Celsius, 150 horsepower. All those descriptions are beautiful, very physical, very mechanical. But after they finished, I asked, okay, so what is the feeling of driving that car at 60 miles per hour? And the whole class went dead silent, because that feeling is completely absent from the mechanical description. You can understand every nanometer of the engine structure, but that doesn't get you to the feeling of driving. And when you think of the brain as a much more complicated engine, you're making exactly the same mistake. An engine can be explained with dynamics, thermodynamics, fluid mechanics, but none of that describes the driver's experience, which is the only reason we care about driving in the first place. Similarly, a brain can be described with voltages, synapses, neurotransmitters, neural networks with billions of connections. But that description doesn't touch the feeling of red pain, joy, sadness. And that's the strength of the example. Explaining how it works does not explain what it feels like. When you see red, science can explain the processing steps. Photons arrive, cones respond, neurons fire, V4 activates. But not a single step in that chain explains why it is experienced as red. It's just mechanical activity, like pistons going up and down. And you can describe pistons your whole life without ever touching the experience of the person sitting behind the wheel. When neuroscience says we've understood the mechanism of vision, what they really mean is they've understood the transmission and processing of signals. They haven't touched the feeling those signals produce. Just like you can know every screw in the car, every crankshaft revolution, every drop of fuel burned, but that doesn't bring you 1 millimeter closer to the feeling of wind hitting your face, the car vibrating slightly, the road opening up ahead. Physical description is never equivalent to subjective experience. And to see how absurd it is to try to derive experience from mechanical description, I often tell students to do this. Look at the engine diagram and show me where the feeling of driving is. Of course there isn't any. And if I tell you, look at the brain activity map and show me where the feeling of red is, you can't either. Because describing structure is one kind of description. Describing experience is a completely different kind. They are not interchangeable. They don't even speak the same language. And what both fascinates and slightly scares me is that we've become so used to physics describing everything that we forget. Experience cannot be compressed into any physical description at all. Even though the brain is the most complex machine in the universe, with 86 billion neurons and 100 trillion synapses, explaining how it works still doesn't move us one step closer to the question, what does it feel like? These are two such different questions that they almost live in two different universes. And it is precisely this gap, this distance between mechanism and feeling, that is the reason we need to rethink the entire assumption that consciousness is just very complicated physics. Because if understanding an engine doesn't give us the feeling of driving, then understanding neurons certainly doesn't give us the feeling of being alive. But things get even stranger when we consider what happens when the brain doesn't just process signals, but begins to combine them into a unified experience. And this is the point where I want you to try an imaginary experiment, one that keeps many philosophers up at night and makes scientists hesitate whenever someone asks too deeply the perfect robot experiment. Imagine we live in the future, where technology has advanced to the point where we can build a robot that mimics human behavior down to every detail. You ask it, how are you feeling today? And it replies, I'm a bit tired, but okay. You tell it a sad story, and it wells up with tears. You show it a sunset scene, and it says, so beautiful. It laughs right on cue when you joke. It hurts when you prick its hand with a needle, and it yells, ouch, with a very genuine expression. All of its behaviors are perfect, to the extent that if I put it at a party without telling anyone beforehand, no one would realize it's not human. So then the terrifying question arises, does this robot have real experience? Does it feel pain? Or does it just behave as if in pain? Does it see red? Or just process a 700 nanometer signal? Does it feel sad when hearing a sad piece of music? Or just simulate the sad expressions we expect? And the scary thing is, current science has no way to answer that question. From a purely physical perspective, the robot and humans are almost no different. Both receive signals, process them, generate responses. The robot uses silicon chips. Humans use neurons. But both are computational systems operating according to physical laws. If you scan my brain with fMRI and scan the robot's processing chip with a similar device, both are just complex patterns of activity. There's no magical glow appearing in the human brain to say, "Aha, this is experience." There's no physical parameter that distinguishes between real pain and pretending pain. There's no equation between the two states of really seeing a sunset and operating according to an algorithm, simulating emotion when seeing a sunset. And this is where the paradox appears. The paradox that philosopher David Chalmers called the philosophical zombie in 1996. A philosophical zombie is a creature that behaves 100% like a human, but has absolutely no experience. If you kick its leg, it will yell, but inside no one feels the pain. The scary thing isn't that zombies might exist. It's that current science cannot distinguish a zombie from a real person. Both are complex physical systems operating according to mechanical laws. Both have the same inputs-outputs. Both can write poetry, laugh, cry, love, fear. If you only look from the outside, like the way physics observes phenomena, you will never know which system has experience and which doesn't. Even if you cut open my brain and observe the activity of 86 billion neurons, you'll only see electricity, chemistry, and structure. You won't see the sweet taste of chocolate, the sadness of a winter afternoon, or the happiness of hearing a good song. You'll only see mechanical activity. And if you observe the robot's processor, you'll only see mechanical activity. So physically, let me emphasize physically, the robot and humans are indistinguishable. This leads to the question science doesn't dare answer. So could it be that consciousness doesn't belong to physical description from the start? If everything observable is identical between a zombie and a human, then the thing that differs between the two systems, experience, does not lie in the observable world. It lies in a completely different realm, where physics has no language to describe it. This is why the hard problem isn't just hard, it's absurd. As I said before, it breaks the entire assumption that complete physics is enough to describe reality. It seems like there's another layer of reality, the layer of experience, that physics hasn't touched yet. And things only get worse when you realize the following. Not only can the robot not be distinguished from humans, even one human cannot be sure another human has experience or not. Science only sees behavior, not feeling. But before we go further into this strange territory, let's look at another classic thought experiment, one full of resonance in philosophy, where we see more clearly than ever the limits of science when trying to touch the inner world. Thomas Nagel's bat. If the perfect robot experiment gives you a slight chill, then brace yourself, because now I want to tell you one of the most famous examples in modern philosophy, the one Thomas Nagel posed in 1974. What is it like to be a bat? Or as I like to joke with students, if you want to understand the limits of science, try becoming a bat. Sounds funny, right? But this is one of the most serious questions ever posed about consciousness. Imagine yourself as a real bat, not in a cartoon, but a creature that lives by sonar. Bats don't see the world like we do. They emit high-frequency sounds. The sounds bounce off objects, and by analyzing the time, intensity, and frequency of the echoes, they build a three-dimensional map of the surrounding environment. This is so amazing that a bat can distinguish a flying insect 2 meters away just from subtle changes in sound waves. Physically, we can describe a bat's sonar extremely accurately. Sound wave equations, reflection, absorption, echo time, signal processing in the cerebellum. I could fill a blackboard with equations about bat acoustics and neurology, but no matter how many equations I write, we still can't answer Nagel's question. What is it like to experience sonar? You can close your eyes and imagine a kind of seeing with sound, but really you're only simulating a human version of sonar, a version imagined by the human mind, not the real bat experience. You can't step into the inside of a bat's life, can't feel space as a network of echoes, can't know how sound becomes image in its subjective world. You can describe the entire physics, physiology, anatomy of the bat, but you can't access its experience. No experiment, no scanner, no model can bring you into the feeling of being a bat. And that's the strength of this example. Subjective experience cannot be accessed from the outside, no matter how much you understand about the physical structure of the system. This exposes a profound limit of the scientific method. Science, from Galileo's time to now, has always relied on the principle of external observation. Measure, record, describe, compare, predict. But subjective experience, like the bat's sonar feeling, your feeling of red, someone's feeling of pain, is a phenomenon that exists from the inside, cannot be turned into external observable data. You can measure neuronal signals in a bat's brain when it uses sonar, but you can't measure sonar feeling. You can measure V4 activity in my brain when I see red, but you can't measure red feeling. You can measure hormones, heart rate, facial expressions of someone in love, but you can't measure love feeling. And from here, a scary conclusion emerges. Science can access everything except the inner life of a subject itself, not because science is weak, but because the nature of the scientific method is not designed to touch the subject. Science describes the behavior of the system, not the experience of the system. When Nagel says we don't know what it's like to be a bat, he's not just talking about bats. He's pointing to a bigger truth. We can't know what it's like to be anyone except ourselves. I can look at you, measure you, attach electrodes to you, analyze your brain waves, but I still can't touch the subjective inner world inside you. Science stands before a closed door, the door leading to the world of experience. And the irony is consciousness only exists behind that door. Everything I can observe about you is not the real you, but only your physical outer shell. And science, by its own methodological structure, has locked itself on the other side of the door. This brings us to an even stranger problem. Not only can science not step into the bat's subjective world, it also can't step into your own subjective world right now. And if science can't touch the inner world, then how can it explain consciousness, something that exists entirely inside? But things will get even weirder when we consider another profound paradox. Your inner world seems like a unified whole. You don't experience color in one place, shape in another, sound somewhere else, all blend into one seamless feeling. Science can measure each separate part, but can't explain this unity. Let's continue delving deeper into the maze of consciousness, and this time we'll face a paradox that makes both neuroscience and physics tear their hair out: the binding problem, or binding problem. You see the world as a seamless picture, a red apple, gently rotating in your hand, light reflecting off its shiny surface, air vibrating with nearby voices, a faint scent wafting from somewhere, all blend together in one single, clear, unified moment. But if you ask the brain how it processes those things, you'll get an extremely opposite answer. The brain processes everything in completely different places. Color is processed in area V4, Shape is processed in area IT. Motion is in MT/V file. Location is in PPC. Sound is in the temporal lobe. Smell is in the olfactory system. Touch is in the somatosensory cortex. Your entire perception, which you think is a seamless film stream, is actually fragmented like a movie split into hundreds of data streams, running on different servers in a giant data center. But somehow, you don't feel those discrete parts at all. You don't see a red running one place, shape running another, motion running elsewhere. You just see one apple, one single, intact object. So what binds all the parts together? This is exactly the binding problem, one of the biggest questions in modern neuroscience. And the bad omen is the deeper we research, the more we see we have no clue. Let's look at the physical picture of the brain. In one place, neurons signal about red. In another, neurons describe a curved edge. Another describes depth. Another describes motion speed. But there's no place in the brain that says all these features belong to the same object, and even less a place that says all these things make up my experience. The brain is like a team of extremely skilled technicians, each only responsible for one part of the project, but no one steps up to claim they're the CEO overseeing the entire experience. What makes things worse is information from brain regions doesn't converge to one central point. Neuroscience abandoned the idea of a consciousness screen in the brain long ago because no such place was found. There's no seat of the soul, no central coordination station, no third eye to view all the data. Everything is processed distributedly, but experience is unified. This is like you're hearing a symphony from 100 instruments, but when checking, you discover each musician is rehearsing in a different room. No conductor, no one hearing what the others are playing. Yet somehow, you hear a complete piece of music. At this point, many researchers try to offer a temporary answer. Maybe neuronal synchronization is the key. When neurons fire signals at the same frequency, they get bound together. Sounds reasonable, right? But remember, synchronization only describes the timing of signals, not the unity of experience. Two neurons can fire at the same time without creating any experience. A computer network can also synchronize pulses, but it has no experience at all. Synchronization doesn't explain why many discrete data become one subject feeling, and this is the most important point. The unity of experience does not lie in any physical description of the brain. No formula says, if there are enough signals from enough brain regions, plus a bit of synchronization, you'll have a self. No equation defines subject. Physics describes the separate parts, but experience is the whole. You don't experience fragments. You experience I, one single, uninterrupted flow. Excited yet? Because the next problem is worse. If you try to explain the unity of experience by pointing to brain activity patterns, you'll soon realize you've made a fundamentally wrong assumption. The assumption that the brain creates experience in the same way mechanical parts combine into a machine. But that's not true. There's no physical mechanism in the brain corresponding to unity, no structure in the brain called the observer. And when you try to stuff experience into a physical description, you'll see it slip away like trying to grasp smoke. This brings us to the big and very dangerous question. If experience doesn't lie in the separate parts, doesn't lie in synchronization, doesn't lie in structure, then where is experience? So let's look at one of the most promising solutions considered for the binding problem in recent decades, neuronal synchronization theory, or synchrony. This idea started gaining traction strongly from the late 1980s, when researchers like Wolf Singer discovered that neurons in different brain regions sometimes fire signals at the same frequency, especially in the gamma rhythms, range around 40 hertz. People thought, aha, this could be the key, Because if the neurons processing color, the neurons processing shape, the neurons processing motion, all fire signals rhythmically together, then maybe that's how the brain marks that those pieces of information belong to the same object in your experience. Sounds reasonable enough, right? Like an orchestra where 100 musicians keep the same beat. And so, people hope that synchrony is the mechanism explaining unified experience. But then reality and physics shows up to shatter that hope. Because when you examine it more closely, you'll see synchrony only explains one single thing: the overlapping timing of signals. It doesn't explain experience. A group of neurons firing synchronously will create, yes, you guessed it, just a group of neurons firing synchronously. No more, no less. There's no physical reason why firing at the same frequency would create the feeling of red, or the feeling of sweet, or the feeling of pain. Try asking the simple question I love to ask students. If 10,000 neurons fire at the same time, does that create consciousness? Then I tell them to increase to 100,000, then 1 million, then 10 million. After a while, they start to see the absurdity. Synchronization is just overlapping signals, not overlapping experience. If you watch a symphony orchestra playing Beethoven, even if they keep perfect time, the music only appears when there's a listener there. Synchronization doesn't create music. It only creates synchronization, and neurons are not the listener. So what are we missing? The problem lies in this synchrony is a description of physical activity, while experience is a subjective phenomenon. The overlapping timing of signals cannot naturally turn into a color or a feeling. There's no leap in physics from signal X appears at t equals sign 0.003 seconds to I'm seeing red. You can put a clock measuring every millisecond on each neuron, but you'll only see electrical spikes rising and falling, not experience. And it's really mythical when many people think that just finding the right physical mechanism, synchronization, resonance, frequency, then experience will automatically emerge. But physics never works in the way that if a signal has a certain feature, it becomes a feeling. No other physical phenomenon does that. Sound waves don't become music without a listener. Photons don't become color without a perceptual system interpreting. So if you believe that timing, just timing, can create experience, then you're attributing to time a magical ability that no physical equation has ever suggested. Synchrony only says these neurons fire at the same time, while experience says, I feel red, I feel round, I feel motion. There's no mathematical transformation that turns one into the other. And the interesting but also a bit sad thing is synchrony doesn't even explain the unity of experience. Imagine 10 different computer networks synchronized with each other's system clocks. That doesn't turn them into one single consciousness. They're just 10 computers running in sync. No I appears when the clocks count the same moment. So why is synchrony considered a solution for consciousness? Because it's the best thing neuroscience can think of. But it's still just a physical description, and physics lacks the most important thing, the experiencer. At this point, we have to admit something very clear. Experience cannot appear just because signals have the same timing. Synchronization is a property of signals, not of the subject. And as long as science keeps looking for consciousness in timing, signals, or any physical property of neurons, we will forever fail. But the next question is even deeper. If neuronal synchronization doesn't create unified experience, then what creates the unified self? And more importantly, why is your experience yours and not someone else's? And this is the point where we touch upon one of the deepest, strangest, and for me, most beautiful paradoxes of consciousness. The question of why I am me and you are you. If all of us are made up of the same kinds of atoms, carbon, hydrogen, oxygen, nitrogen, and if all brains operate based on the same electrochemical principles, then what creates me? What creates you? What turns a neural structure into a subject, into a unique point of view that cannot be copied? Try thinking in a physics style. A neuron doesn't know if it's in your brain or mine. It doesn't have a name tag. It doesn't have a personal ID. It only knows to fire electricity when stimulated, exactly according to the Hodgkin-Huxley equations from 1952. And if you swap the neuron in my brain with one in yours, assuming the swap doesn't break the connections, those two neurons would still operate just like before. There's nothing that identifies them. So if neurons don't carry personal identity, and physical structure doesn't contain subject, then why is my experience, and not anyone else's? Why aren't you experiencing the feelings in my head right now? Why am I not experiencing the feelings in yours? Physics has no answer, and this is exactly the subjectivity problem. Consciousness is not just experience. It is experience from a unique point of view. No one but you can access your inner world. No one but me can access mine. This creates a barrier that all external observation methods of science are completely powerless against. You can measure my brain waves, take fMRI scans, analyze hormones, record electrodes in every synapse if you want. You still can't touch my feeling. You only see neuronal activity, not the person who is feeling. Try a little imaginary experiment. If I created a perfect physical copy of your brain, identical down to every synapse, every molecule, and activated it with your exact neural data, would you appear in it? Or would it just be a machine operating like you? And if you appeared in both the copy and the original, then would there be two yous? That's so absurd that it forces us to admit that consciousness doesn't lie in physical structure, because physical structure can be copied. What cannot be copied is the subject. That I exists only once, at one unique position in the universe. And now let's look back at something science loves to do. Describe systems from the outside. This works for stars, for planets, for machines, for everything without an inner life. But with consciousness, a phenomenon whose essence is existing from the inside. The external observation method can never reach the real entity. This isn't the scientist's fault. This is the limit of physics. Because physics has no concept of inside. It only has position, velocity, energy, spin, charge. There is no physical quantity corresponding to the experiencer. There is no variable in Schrödinger's equation that says, this is the experience of individual A. The physical universe seems completely neutral to personal identity. It describes structure, but experience doesn't lie in structure. It describes motion, but the subject is not motion. It describes information, but the subject is not information. The subjectivity problem is a reminder that consciousness is not just a collection of brain functions, but a unique perspective, irreplaceable, unsimulatable, unobservable from the outside. And the biggest paradox is the deeper neuroscience explores, the clearer this problem becomes. When you sit in front of the person you love, you don't just see them, you see from inside yourself. When you hear a piece of music, you don't just analyze frequencies. You have a stream of sensation running through your body. When you feel pain, that feeling is yours. No one can replace it. So how can physics, which only talks about particles and fields, describe something that the particles and fields themselves don't feel? This is the biggest barrier in explaining consciousness with physics. Physics is the science of the objective world. while consciousness is the reality of the subjective world. These two things are not just different, they live in two different dimensions. And when you realize this paradox, you start to see clearly that the problem doesn't lie in the complexity of the brain, but in the very way science approaches the world. And now, to see more clearly the helplessness of physics in explaining consciousness, let's start from the smallest level, the most basic level that physics describes, atoms and fields. If you zoom into your brain down to the particle level, you'll see something both beautiful and strange. Most of everything is empty space. An atom has a diameter of about 10 circumflex minus 10 vec meters, but its nucleus, where almost all the mass is in latest 10 circumflex minus 15 vec meters wide. That means the atom is empty to 99.99999999999%. And those electrons you imagine as tiny balls orbiting the nucleus actually don't exist as objects. An electron doesn't have a definite position. It's a cloud of probability described by Schrödinger's equation from 1926. You can't point to a spot and say it's here. You can only say it has a chance of being here. That's how physics describes the world, by probabilities, by states, by fields. But the gentle question I want to ask is, do you feel pain in the form of probability? Do you feel red in the form of a wave function? No. Experience is clear, certain, whole. It's not probability, it's happening. This leads to a strange conclusion. When you zoom into the brain, the experience you're feeling right now disappears. You don't see red. You only see 700 nanometers photons. You don't see emotion. You only see sodium ions entering neurons. You don't see consciousness. You only see oscillating electromagnetic fields. Even the electromagnetic field, which Maxwell described beautifully in 1865, has no room for experience. The field is just the variables, E and B, changing over space and time. But no one looks at Maxwell's equations and says, this is where sadness lies, or this is where consciousness appears. In the microphysical description, there's no place reserved for experience. There's no symbol called qualia. There's no quantity called feeling. There's no equation describing the presence of a subject. It's all just field oscillation, particle interaction, energy conservation. And that's exactly the problem. If consciousness is real, if experience is real, but they don't appear in the microphysical description, then either physics is incomplete or experience is not something describable by physics. Many scientists, including me when I was young, once believed that consciousness is just more complex physics. But when you look deep into the physical nature of matter, you realize the opposite. The smaller matter gets, the more experience disappears. This doesn't make sense if you think consciousness is built from small parts of matter, because if the small parts don't contain experience, and the whole system has no mechanism to naturally produce experience, then we're stuck with a paradox. It's like trying to build a poem out of grains of sand. Grains of sand don't contain meaning, and stacking billions of grains of sand doesn't create meaning, unless there's a person reading the poem. But physics has no reader inside it. You can look into the brain with an electron microscope and see proteins, lipids, synapses, but not the self. You can describe a neuron with the Hodgkin-Huxley equations, but not describe fear. You can simulate the entire activity of a neural network, but not simulate experience. This makes us realize a profound truth. Consciousness cannot just be atoms. Atoms don't carry subjectivity. Electromagnetic fields don't carry subjectivity. Electrons, quarks, gluons don't know sadness, joy, pain, red, sweet. If basic matter has no seed of experience, then how does experience emerge from a collection of non-experiencing things? This is the paradox of modern physics. When facing consciousness, we describe the world with components that have no experience, no subjectivity, no subjective content, then hope that somehow, when we stack them complexly enough, consciousness will naturally pop up. But no physical theory, from Newton to Lagrange, Maxwell, Einstein, Dirac, Feynman, yes, including me, and to modern quantum mechanics, explains the leap from matter experience. And if physics keeps looking for consciousness in atoms, in fields, in electrons, then it will forever lose track of consciousness right from the start of the hunt. But the problem is even deeper. Not only do atoms not contain consciousness, even the fields and processes the brain creates when active don't contain consciousness. That's why some scientists turn to a new idea. Maybe consciousness doesn't lie in neurons, but in the electromagnetic field that neurons create. Sounds appealing, but does it solve the problem? So let's look at one of the most interesting efforts to rescue consciousness from the claws of pure physics, the electromagnetic field theory of consciousness, EM field theory of consciousness. This idea sounds appealing. Every time a neuron fires, it creates a tiny electromagnetic oscillation. Billions of neurons working together create a complex electromagnetic field spreading across the brain. This field changes every millisecond, containing information about the rhythm of neural activity, the degree of synchronization, the oscillation frequencies. And so some researchers propose that maybe consciousness doesn't lie in neurons. It lies in the brain's own electromagnetic field. Sounds very scientific, right? We can measure the electromagnetic field with EEG, MEG. We can observe alpha, beta, gamma waves oscillating. And when humans lose consciousness in anesthesia or deep sleep, the electromagnetic activity becomes chaotic or slows down. When they wake up, the electromagnetic field suddenly becomes more organized. This makes many people say, "Aha, consciousness is the electromagnetic field." I have to admit, the idea is very seductive. If neurons are too discrete to explain unified experience, then a continuous flowing electromagnetic field enveloping the entire brain seems more fitting. But then physics shows up, flashlight in hand, shining into the dark corners, and the whole idea starts to wobble. Because if you say consciousness is the electromagnetic field, then I'll ask right back, so does a radio have consciousness? A radio has an electromagnetic field. A phone has an electromagnetic field. The Wi-Fi in your house creates an electromagnetic field. The sun creates an electromagnetic field, strong enough to kill all electronic devices if it flares up big enough. But no one thinks your home radio is heartbroken when the signal is weak. No one believes your microwave is sad when you forget to open the door. No one thinks Wi-Fi waves no headaches when you download too heavy a movie. And most importantly, there's no physical reason why an electromagnetic field would feel anything. The EM field is a phenomenon described extremely clearly by Maxwell's equations. There's no place in them saying that the EM field has emotions, has a subject, or has experience. An electromagnetic field is just the change of two quantities, E and B, over space and time. That's it. Beautiful, but mindless. Remember, physics doesn't distinguish between the electromagnetic field in a human brain and the electromagnetic field in a microwave. They obey the same equations, same laws, same nature. If consciousness really is the electromagnetic field, then we have to accept the bizarre conclusion. The microwave is having a sad afternoon, and your home antenna is pondering the purpose of existence. This isn't just wrong. It's completely without physical basis. But let's examine more closely why the electromagnetic field seems related to consciousness. When you're awake, The brain's electromagnetic activity is organized. When anesthetized, this activity collapses into chaos. That proves one thing. Consciousness needs an ordered form of physical activity. But that doesn't mean consciousness is ordered physical activity. The EM field can contain information, but it doesn't contain feeling. It transmits signals, but it doesn't sense signals. It has mathematical shape, but it doesn't have inner life. A fun example I like to use. If you look at the electromagnetic field spectrum of the brain, while the person is listening to Beethoven's music, you'll see waves at 10 hertz, 40 hertz, 80 hertz. But the music doesn't lie in those waves. Those waves don't hear the music either. You hear, you experience. The field just oscillates. A violin can resonate at 440 hertz when playing the note A, but resonance isn't the musical note. Once again, physics describes structure, not experience. And the electromagnetic field theory makes the same mistake all other physical theories make. It confuses how the brain works with what the experiencer feels. The electromagnetic field is how the brain transmits and processes information. But experience is what is felt from a subjective point of view. There's no Maxwell equation that turns E and B oscillations into red feeling. There's no integral that turns field intensity into pain feeling. There's no derivative that creates the self. And if you try to stuff consciousness into the electromagnetic field, you just shift the problem from neurons to another physical phenomenon. But don't solve the essence of experience, because experience isn't electricity, isn't magnetism, isn't field, isn't oscillation. Experience is something completely different, something physics has never touched. But when field theories fail, some scientists seek an even stranger idea. Could consciousness be a quantum phenomenon? Sounds appealing, mysterious, vague, just the kind of thing people like to attribute to consciousness. But does it solve the problem when electromagnetic field theory doesn't save consciousness? Some scientists, especially those who've long loved quantum mechanics, start dreaming of a bolder possibility. Consciousness is a quantum phenomenon. Sounds very dramatic, very science fiction, and especially very fitting with the mythical cloak the public has draped over quantum mechanics for decades. But let's examine it seriously, because this hypothesis isn't baseless. It was proposed by two respected figures, Roger Penrose, the mathematician physicist who won the Nobel in 2020, and Stuart Hameroff, an anesthesiologist. Their hypothesis, called OR, says that consciousness doesn't emerge from the classical activity of neurons, but from quantum processes occurring in microtubules, those super small protein tubes inside nerve cells. This idea is appealing because it opens a new door. If classical phenomena don't create experience, maybe quantum, with its indeterminacy, superposition, quantum entanglement, is what can bring the magic. But you know what? Every time someone tells me quantum explains consciousness, I have to smile lightly, because if you want quantum to explain consciousness, you have to face two huge problems. First, the brain is too warm, too wet, and too noisy to maintain delicate quantum states. Quantum phenomena like superposition or entanglement usually only exist in extremely cold and isolated environments, like in superconductor experiments or vacuum chambers. But your brain is 37 degrees Celsius, full of water, full of ions, full of molecular collisions, a terrible environment for quantum coherence. Many physicists have pointed out that quantum states in microtubules, if any, would decohere in about 10 circumflexed minus 13 seconds, too fast to play a role in neural activity that happens in milliseconds. Hameroff and Penrose have counter-arguments, but most of the scientific community views this idea as too far-fetched from biological reality. Second, and more importantly, even if consciousness is quantum, that doesn't solve the main problem. You can replace neurons with transistors, Replace transistors with vacuum tubes. Replace vacuum tubes with quantum mechanisms. But you haven't advanced one step in answering the question, why is there experience? Superposition doesn't naturally become red. Quantum entanglement doesn't naturally become pain feeling. The wave function doesn't naturally become the self. Superposition only says a system can be in multiple states at once, but experience isn't in multiple states at once. It's happening uniquely at one point of view. Entanglement says two particles can be linked so that changing the state of one affects the other instantly. But that has nothing to do with the feeling of smelling jasmine or hearing rain. No matter how strange quantum is, it's still just a physical description. It describes probabilities, not subjects. It describes states, not experience. It describes the evolution of the wave function, not read in the mind. And this is the point I want you to feel deeply. We're making the same mistake over and over. We take a physical phenomena, neuron firing, electromagnetic field, quantum superposition, then hope that at a sufficiently complex level, experience will pop out, like hoping that if you stir milk fast enough, it will become Beethoven. But physics gives us no basis to believe that experience can emerge from physical behavior, whether that behavior is classical or quantum. Remember, quantum mechanics wasn't created to explain consciousness. It was created to explain electrons, atoms, absorption spectra, photoelectric effect, superconductivity. There's no equation in quantum mechanics, from Schrödinger to Dirac to Heisenberg, that contains the variable subjective experience. There's no symbol in quantum mathematics representing memory, joy, pain. If we use quantum to explain consciousness, we just trade one big mystery for a bigger one, but make no progress. And if quantum doesn't help us understand experience either, then maybe it's time to try another mind-bending experiment, one that shakes our notion of brain equals sign consciousness even more. What happens if we copy the entire brain activity and run it again in another system? Would experience appear in the simulation? Let's try another imaginary experiment, this time one that makes scientists sweat even more than quantum stuff. The playback paradox, the paradox of replaying neural signals. Suppose you're a mad, ambitious engineer and you want to copy a human's experience, not behavior, not memories, but the actual current experience. You place thousands of electrodes in a person's brain, recording every electrical spike, every voltage change, every ion flow, every millisecond, across all 86 billion neurons. You store all this data in a massive supercomputer. Assume you have the technology to do this, something far beyond human capability today. But in a thought experiment, we allow it. Now you have what many people imagine is a map of consciousness, the entire signals, a gigantic symphony with trillions of neural notes, and you decide to replay that symphony. You create an artificial brain, or even just a computer array, and feed into it the exact signals you recorded. Every spike with the right timing, the right intensity. The question is, does that system have experience? Does it see red when the visual signal passes through the equivalent V4 area? Does it hear Beethoven when the auditory signal passes through the equivalent A1 area? Does it hurt when the neural activity pattern related to pain is replayed? It sounds reasonable. Same signal, same activity, same experience. But hold on, because this is where the paradox appears. If you can replay the signals once, you can also replay them twice, or 5 times, or 1,000,000 times at the same moment. So does the copied experience appear 1,000,000 times? That sounds absurd to the point of being unacceptable. If you replay the signals at half speed, does the experience get slowed down too? If you replay them in reverse time, does the experience run backward? If you replay them in scrambled order, does the experience become meaningless? Clearly, signals are not experience, just like sheet music is not sound, unless there's someone listening. And the problem is even deeper. Neural signals are not the thing that creates experience. They are just the thing recorded from experience. The playback paradox destroys the idea that copying information alone copies consciousness. If signals are enough to create experience, then replaying them on a computer also creates experience. But if so, then any simulation with enough detail, for example, a brain simulation on a server, would also have experience. So where is the experience? In the hardware? In the software? In the data? There's no place that fits. If signals are important, the order of signals is also important. But if the order of signals is important, then all the physical factors related to rhythm, environment, brain structure are also important. And if everything is important, then you cannot separate experience from the system that creates it. The playback paradox proves one thing. Experience cannot be separated from the subject. Signals are not experience. Sequences are not experience. Structure is not experience. Experience is something that happens to someone. It is tied to a point of view, something that playback cannot recreate. You can play back a recording of my voice, but you don't recreate the speaker. You can watch a movie again, but you don't recreate the person living in that movie. The playback paradox exposes a serious limit of science. We can describe and copy activity, but we cannot copy the subject. And this shakes the foundation of the assumption that consciousness is computation or information. If experience cannot be copied just by copying signals, then what does experience depend on? On matter, on structure, or on something physics has never described, the continuity of the subject. To understand this paradox deeper, let's try an even more extreme thought experiment, one that gives many people goosebumps the first time they hear it. If you not only copy signals, but copy the entire brain structure at one point in time and freeze it into a book, does that book have consciousness? Let's continue pushing the thought experiment to an even weirder level, a level where if you tell it to a computer scientist, they'll often look at you as if you just said a cat can solve Schrödinger's equation. Suppose you don't just record neural signals over time, like in the playback paradox, but you record the entire brain state at a single point in time, every membrane potential, every neurotransmitter molecule, every ion distribution, every synaptic connection, every protein state in microtubules, every tiny current in those little axon segments. And then you compile all that information into a gigantic list, maybe hundreds of terabytes or more. After that, you print the entire list into a book, a horrendously thick book, to the point you'd have to pull it with a cart. Now look at the book and ask the most important question. Does this book have consciousness? Does it think? Does it remember? Does it hurt when you bang hard on page 500? You can slam it on the table, throw it on the ground, but it will never yell, ouch. It has no experience, no feeling, no subject. But why? It contains all the information about a brain. If you believe consciousness equals sign information, then that book must have consciousness. And if you don't believe that, which I guess you don't, then you've just inadvertently admitted that information by itself is not experience. A description of a brain state is not an experiential state. Information about consciousness is not consciousness. Try imagining similarly. You can write out all of Beethoven's music on paper with every note accurate, but that paper doesn't hear the music. You can record a recipe in a book, but the book doesn't taste the dish. You can describe a sunset scene with thousands of words, but the book doesn't see it. Information is not experience. Never is experience. So why do many scientists believe in that? Because in the world of computation, Information is the foundation. Computers process information. Brains process information. And people jump quickly to the conclusion, if processing information is the same, experience is the same. But the book destroys that argument. Let's examine closely. The book has all the information, but no process. It doesn't compute. It doesn't change. It doesn't respond. It only describes a moment. But if you want to say consciousness is information being processed, I'll ask, so is there a difference between information processed by a computer and information processed by a brain? If there's no essential difference, then computers must have experience. But no one believes a laptop is sad when the battery is low, or a Wi-Fi router is anxious when overloaded. And if you say consciousness needs the special physical structure of the brain, then you've admitted that consciousness is not pure information, but needs a material factor, a factor the book doesn't have. So what is the deciding factor? No one knows. Some say consciousness is process, not state. But if so, imagine you run a program simulating a brain on a computer, a perfect simulation, step by step. Does that program have experience? If yes, you've accepted that silicon can also have consciousness. If no, then why doesn't the same process create the same experience? The book forces you to face the following paradox. Information can describe experience, but cannot create experience, because experience is not something that can be compressed into data. It is something that happens to a subject, and the book has no subject at all. The book only knows in the abstract sense you attribute to it, like a map knows the streets. In reality, it knows nothing at all. And this very difference between description and experience, between information and subject, is the biggest intellectual hole in the theory of consciousness equals sign information. The book doesn't know pain. It doesn't know love. It doesn't know red. It doesn't know it exists. It doesn't know anything. And if an object containing all the information about a brain still has no consciousness, then information cannot be the essence of consciousness. In other words, consciousness is not what is recorded, but what is living. Consciousness is not data, but the stream of experience that cannot be separated from the subject experiencing it. The split brain experiment is one of the most beautiful and horrifying discoveries in neuroscience. And if you've never heard of it, brace yourself, because this story will make you look back at yourself with a doubt. Is there really only one me in here? The background is this. In the 1960s, doctors faced patients with extremely severe epilepsy, seizures spreading across the brain because the two hemispheres constantly exchanged signals too strongly. The last resort cut the corpus callosum, the neural bridge, with over 200 million axons, which is the main communication path between the two brain hemispheres. People expected the patients would lose some important cognitive functions, because who would think you could split a brain in half without causing disaster? But the strange thing happened. Patients still talked normally, walked normally, thought normally. If not tested carefully, you wouldn't know their brains had been split. But when scientists started designing sophisticated tests, the chilling truth emerged. Remember, left vision goes to the right brain. Right vision goes to the left brain. Now, if you flash an image of a chicken to the right visual field, that is to the left brain, the language hemisphere, the patient says, that's a chicken, no problem. But if you flash an image of a shovel to the left visual field, that is to the right brain, no language center, the patient will say, I don't see anything. Sounds reasonable? Hold on. When you place a series of objects in front of them and ask them to choose the item matching the image they saw, the left hand, controlled by the right brain, quietly picks up the correct shovel. The left brain lies. I didn't see any image at all. But the right brain acts based on the image it just received. Two consciousnesses existing in parallel. One side knows but can't speak. The other side can speak but doesn't know what the other saw. And it gets even stranger when asking them why the left hand just picked up the shovel. The left brain, which loves making up reasons to fit logic, immediately invents, all because to shovel chicken poop. A completely fabricated explanation, but very confident. What are we witnessing? One body, two streams of experience. One flesh, two distinct perceiving subjects. One human, two eyes that can't communicate with each other. This throws a bucket of cold water on scientific intuition. We often think consciousness equals sign brain, and the brain is one thing, so consciousness is also one thing. But the split brain experiment proves the opposite. Consciousness depends on the internal communication structure in the brain. And when that structure is split, experience is also split. No physical equation describes this process. No Maxwell formula says if you cut the bridge, the number of subjects increases from 1 to 2. No classical or quantum physical model allows us to predict that in a single body, two separate streams of experience can exist. And the scariest thing, split brain patients don't feel split at all. Each hemisphere believes it is the only one in the body. Two consciousnesses coexist without either knowing about the other. This leads to a profound question. If just cutting the corpus callosum creates two consciousnesses, then when the brain operates normally, what unifies experience into one me? And more importantly, what is the nature of the self if it can be separated just by one surgical operation? This isn't a biology problem, but a problem of the subject, something physics has no tools to describe. Split brain pulls back the curtain on consciousness and shows us it's far more fragile than imagined. It's not a single block, not a physical entity like an apple or a rock. It's a phenomenon dependent on the flow of information in the brain, but not identical to that information. And if consciousness can be split, then can it be duplicated, merged, transferred, or even disappear without anyone noticing? These questions lead us to an experiment that shakes the concept of the self even more than split brain. The teleportation experiment, where you have to answer the most chilling question. If we perfectly copy you and destroy the original, which one is you? Suppose you step into an instant teleporter, the exact kind in science fiction you've seen thousands of times. And I, as an old big-mouth physicist who likes destroying other people's mental peace, decide to explain to you what really happens inside that machine. Not the Hollywood version, but the pure physics version. The machine will scan your entire structure, every atom, every molecule, every electron position, every spin state, every chemical bond, then send that description to another place. At the destination, another machine will assemble matter into a perfect copy of you, with the exact structure, exact memories, exact habits, exact mood, exact preference for morning coffee. But there's one detail Hollywood never likes to mention. To create a perfect copy, the machine must destroy the original. That's the only way to avoid two yous existing, fighting over bank accounts and lovers. So when you step into the machine, it scans, then boom, no more you, no more position, no more biological energy, no more any activity, just data. And at the destination, you appear again. The copy opens its eyes, breathes, smiles, and thinks there was no interruption in the stream of experience. From that copy's perspective, you blinked once on Earth and opened your eyes on Mars. But from physics' perspective, you, the original, have been completely erased. And this is the question that keeps both philosophers and physicists up many nights. Is that copy you? If you say yes, then you accept that the self is just information structure, not the stream of experience. But if you believe that, I can copy you 10 times. So do 10 copies all have the same you? Which experience is real? Are there 10 identical consciousnesses coexisting? If you say no, the copy isn't you, then congratulations. You've just admitted that there's something beyond pure physics that determines the self, something that can't be copied by information, something the teleporter can't transmit. And if so, the teleporter kills you and creates a stranger who believes they're you. Both answers are equally bad, and that's when we know we're facing a real mystery. But let's dig deeper. Suppose the teleporter has a technical glitch and doesn't destroy the original, meaning now there are two yous, one standing on Earth, one on Mars, both saying, I'm the real one. Experience branches, two independent streams of consciousness, two different futures. So which one is the self continuing from the past? Both? Neither? If you're the one on Earth, you clearly feel you didn't teleport. If you're the one on Mars, you clearly feel you did teleport. So which is the real experience? From physics perspective, both are correct. From the subjective perspective, only one is correct. So consciousness cannot be described by objective physics, because physics has no concept of internal point of view. All of quantum mechanics, quantum field theory, relativity, none has a variable I. None distinguishes between original and copy, if they're identical down to every electron. Physics only says two identical configuration, same state. But consciousness doesn't operate that way. Consciousness is not a copy. It is the continuous feeling of a unique subject, and that's what the teleporter paradox exposes. Experience has a continuity that physics cannot describe. When you're destroyed, your stream of experience ends too. The copy may remember your memories, but those are its memories, not yours. It only resembles you, but isn't you. Like an actor playing you never becomes you, no matter how perfect. So what does the teleporter destroy? It destroys the self, something modern science cannot define. And the problem isn't in the technology. The problem is in how we understand reality. If consciousness is just physics, the teleporter must preserve consciousness. But if consciousness isn't pure physics, the teleporter is just a sophisticated killing machine. The teleporter paradox tells us a hard-to-swallow truth. We don't know what I is. We don't know what experience is attached to. We don't know what links the current moment to the previous one to form a unique self. And if we don't know that, we cannot say consciousness is atoms, fields, information, or anything physics describes. The only thing we know for sure, there is a subject experiencing, and science has never described that subject. But the problem gets even messier when you realize that experience is not only private, it also has a present quality, while the brain processes signals slowly and discreetly. That leads to one of the deepest mysteries about consciousness. Why do you always feel like you're living in the present, even though the brain is always delayed by a few milliseconds? There's one argument that every time I hear it, I both laugh and get a little annoyed, like when someone claims an electron knows which path to take. It's the argument. Consciousness is just an illusion. It sounds smart, sounds modern, sounds like a slap to idealism. But in reality, this is one of the most self-contradictory statements in all of philosophy and neuroscience. Let me put it bluntly, in my own style. If you say consciousness is an illusion, you've just proven that consciousness cannot be an illusion. Here's why. When you call something an illusion, you're saying, 1, there is an experience. 2, that experience does not match reality. If you see an oasis in the desert, but it doesn't exist, that's an illusion. If you hear someone calling your name in the wind, but no one is calling, that's an illusion. But in every case, there has to be someone experiencing that illusion. No experience, no illusion. So saying consciousness is an illusion is like saying this voice is fake, but I'm not actually hearing anything at all. It collapses on itself immediately. An illusion cannot illusion itself. A dream cannot dream itself. An echo cannot create itself without an original sound. The one thing that is absolutely certain in this entire universe is that there is experience happening. Everything else, quark particles, the Higgs field, time, space, is inferred from experience. You've never seen an electron. You only see a streak of light in a cloud chamber and infer the electron. You've never heard a photon. You only see its impact on the retina and call that light. So the mixture of experiences that the brain creates is the raw data of perception. It cannot be called an illusion because it itself is the foundation upon which everything else is built. Consciousness is not something you prove. Consciousness is what you use to prove everything else. That's why philosopher David Chalmers says you can doubt anything except that there is something it is like to be you. And this is the point many neuroscientists miss when they say consciousness is just an illusion created by the brain. They are using consciousness to deny consciousness itself. They're like someone standing on a ladder and then sawing off the ladder they're standing on. They're like someone writing a book to prove that writing doesn't exist. They're like a computer running a program to prove that computation is an illusion. This is not just logically wrong. It's empirically wrong. Let's take a simple example. Pain. You can tell someone that pain is nothing but neural signals, but that doesn't make the pain disappear. You can describe every biological mechanism, but you cannot reduce the experience of pain just by theory. Experience has a degree of reality different from physical description. No Maxwell equation contains the variable sharp pain. No Schrödinger equation contains the variable deep sadness. No Einstein tensor contains the variable I'm happy. And no matter how much you turn the standard model upside down, you won't find red in any particle. So consciousness is one of the strangest things in nature. It doesn't appear in physical description, yet it is the most certain thing for every individual. If a scientist says consciousness doesn't exist, ask them who's saying that. If they answer I am, then the game is over. Consciousness cannot be eliminated. It is the only fixed point in the entire maze of knowledge. And if it cannot be eliminated, it cannot be an illusion. It is a fact. It is the foundation. It is what every equation must fit, rather than something equations eliminate. And that's why we must rethink the entire way physics describes reality. If consciousness cannot be reduced to an illusion, physics must face the uncomfortable truth. Reality contains subjective points of view. If you followed me this far through the emotionless robot, Nagel's bat, the teleporter paradox, split brain, playback paradox, and even the consciousness is an illusion, argument that collapses like a broken bridge, then you'll see that we're standing before a rather strange abyss in science. Every physical description fails when trying to explain subjective experience, not because we lack data, not because we need better microscopes, more fMRIs, more colliders. No, we fail because perhaps we're asking the wrong question. And this is the moment I have to say what many scientists hate to hear most. Maybe consciousness isn't something that is created. Maybe it is something fundamental, like the way we treat mass, charge, spin in physics. We don't explain them from something else. We just describe how they behave, how they interact. No one asks, where does mass come from? Unless you're hanging out with particle physicists and they start talking about the Higgs field and you immediately pretend you have a sudden appointment. But the point is, in most of physics, mass is a fundamental quantity. We can't reduce it to anything smaller. We just describe how it affects the world. Now let's try applying the same thinking to consciousness. Maybe the question, How does experience arise from neurons is completely meaningless, like asking how does mass arise from color, or how does electric charge arise from geometry. Maybe we're trying to force consciousness into a theoretical framework that was never designed to contain it. Maybe consciousness is not a byproduct of matter. Maybe consciousness is a fundamental property of reality. I'm not saying everything has consciousness like in New Age idealism. I'm not telling you to apologize to the nail you just stepped on. I'm just saying that maybe consciousness is like spin, a property that exists, not deducible from anything else, but describable through laws of interaction. Instead of asking why is there experience, we might have to ask, in this universe, what physical conditions does experience correspond to? This isn't giving up. This is how physics progresses. Recall history. Newton didn't explain what gravity is. He just described it with equations. Maxwell didn't explain what charge really is. He just described its variation through electromagnetic fields. Schrödinger didn't explain what an electron really is. He just described the evolution of probability. Physics doesn't start by understanding the ultimate nature of everything. It starts by finding laws that connect the phenomena we observe. And then when those laws are strong enough, beautiful enough, consistent enough, we accept the fundamental quantities as nature's definitions. If consciousness cannot be reduced to atoms, charge, fields, information, or simulation, then maybe it is a fundamental quantity, meaning instead of asking why there is experience, we can only ask what physical configuration, under what conditions, and at what scale does experience correspond to. Like charge has Maxwell's equations, spin has Dirac's equation, mass has Einstein's equation. Consciousness may need entirely new equations, something physics today has never even imagined. And here's the interesting part. If consciousness is fundamental, we must revisit the entire current physical framework, which was built on the premise that everything can be described from the outside. But consciousness has an inside. It has a subject. It has a point of view. It has what it is like. If this is fundamental, current physics is missing a huge piece, a theory of the subject. I'm not saying this is certainly true. I'm just saying we must be humble enough not to rule it out. When I was alive, I always told students, you have to keep a mind open enough to accept new ideas, but not so open that your brain falls out. And the idea that consciousness is fundamental is exactly the kind of idea you have to hold your brain very tightly for. This isn't retreating into mysticism. This is a humble but scientific philosophical stance. When a phenomenon cannot be reduced by any existing descriptive framework, we must consider the possibility that it lies on a different fundamental layer of reality. Maybe consciousness is a new constant of nature, a kind of field yet to be discovered, a property not dependent on matter, but interacting with matter to produce experience. If this is true, then an entirely new school of physics will have to emerge, just as quantum mechanics once emerged to solve what classical mechanics failed at. And imagine what that would open up, a science that can map both the outside and the inside of reality, a physics that can draw connections between configurations of the universe and subjective experience, a theory where consciousness isn't something to be eliminated, but a variable in the equation. It would change philosophy, change science, change questions about the self, change how we understand life, death, and everyday experience. This isn't empty promise. This is the only direction left if we remain intellectually honest. When every reductionist path fails, we must consider the possibility that consciousness is foundational. It isn't something we add to physics. It may be something physics has overlooked from the very beginning. And if you think that sounds too bold, remember, there was a time people believed the sun orbited the earth. That time was absolute. That electrons were tiny billiard balls. That the universe was static. Every time physics dared to accept that its intuition was wrong, we stepped into a larger universe, and perhaps, just perhaps, we're standing before the biggest door of all. The universe isn't just described by physics. The universe must also be experienced. Consciousness isn't an intruder into the physical world. It may be a dimension of the world we haven't yet learned how to measure, but if consciousness is fundamental, that leads to the final question. The biggest question a physicist can ask. The universe is vast, but why is only a tiny corner of it aware that it exists? If we truly accept the possibility that consciousness may be a fundamental quantity of the universe, something irreducible, something that cannot be broken down into atoms, cannot be mechanically generated from electric fields or quantum processes, then that opens a completely different way of looking at yourself. You are not merely a collection of molecules randomly lighting up according to biochemical equations. You are the product of an entire 13.8 billion year cosmic history, and deeper still, you may be a property the universe has always carried, but only reveals when structure becomes complex enough to reflect upon itself. Think about that journey. Hydrogen formed a few 100,000 years after the Big Bang, drifting in the primordial radiation sea. Then hydrogen clouds collapsed to form the first stars, and in their cores, furious nuclear fusion forged carbon, oxygen, nitrogen, the elements that make up your body. Those stars exploded as supernovae, scattering matter across galaxies, forming planets, and on one of those planets, a speck of dust orbiting an ordinary star at the edge of the Milky Way, matter began organizing into self-replicating molecules, then cells, then nervous systems, then a brain with 86 billion neurons. And somehow, after 13.8 billion years of playing quantum field Legos, the universe produced something it never had before, the ability to look back at itself. As cosmologist Carl Sagan once said, "We are a way for the cosmos to know itself." You are not just a way for the universe to know itself. You are the only event in the entire physical description that equations didn't predict. Experience. No Maxwell equation leads to red. No Schrödinger equation leads to the feeling of homesickness. No Einstein tensor leads to sadness, joy, curiosity. And yet all of those things are happening right inside your head as you read these lines. This, if you pause for just 1 second to feel it, is one of the most extraordinary things that has ever existed in the history of the universe. Imagine the universe went through nuclear chain reactions in stellar cores, created spiral galaxies, supermassive black holes, gravitational waves, the Higgs field, primordial quantum fluctuations. But the only thing among all those wonders that can ask about the very nature of existence is consciousness. A photon doesn't ask, "What am I?" A proton doesn't ask, "Where did the universe come from?" A neutron star doesn't wonder, "Why am I so heavy?" But you do ask. You are the only phenomenon that can turn the lens inward on its own brain and try to understand what it's doing. And let me say this very slowly. Nothing in current physics can explain that. This doesn't make physics weaker. It makes the universe more profound. Perhaps consciousness is a layer of reality we've only touched the edge of, a layer that, if understood, would not only explain the brain, but the very purpose of material evolution in the universe. Now let me take you into an image I love telling students. Imagine you're standing on a cliff at night, looking out at the entire sky. The light you're seeing from stars thousands of light years away is electromagnetic waves emitted by electrons jumping energy levels. Physics describes that perfectly, but the feeling you have when looking up at the sky, the awe, the smallness, the curiosity, that is something physics cannot describe. The universe may produce the light you see, but only consciousness can produce what that light becomes inside you. And when you look at the night sky, you're looking at a process so long it's unimaginable, from quantum fluctuations in the early universe, to galaxy formation, to the solar system, to planet Earth, to single-celled life, to animals with nervous systems, to upright humans, to a brain that knows how to question itself. You are the temporary answer of the universe to the question, is there anything there to understand? I want you to see this wonder, not through philosophical emotion, but through the eyes of physics. The atoms in your brain were once star ash. The electromagnetic fields in your brain were once fluctuations in the plasma of the young universe. The chemical bonds in your neurons were once products of stars that died before the sun existed. But consciousness, the feeling that is reading these lines right now, is something completely new that appeared. It didn't exist in the stars. It didn't exist in protons. It didn't exist in equations. It is the emergence of a new dimension of reality, the subjective dimension. And if the universe could produce that dimension, then perhaps your role in the cosmic story is not random, but an inevitable leap from matter to awareness. Perhaps consciousness is how the universe checks itself. Perhaps consciousness is a property written into the structure of space-time from the beginning that is only now revealing itself. Or perhaps consciousness is evidence that our physics is not yet full enough to embrace all of reality. I don't know, but I do know this. Nothing in your life is more certain than the fact that you are experiencing something right now. And when a phenomenon is the most certain thing in the universe, yet science cannot explain it, that is where science must start digging deeper. And so I want to end the way I always do. Not with an answer, but with a question. A question only you can answer, because it doesn't lie in any equation, any laboratory, but in your own subjective experience. If you had to bet on one solution to this mystery, what do you think consciousness really is? A product of matter, a fundamental quantity, an undiscovered dimension of the universe, or something that the language of physics is still not sufficient to reach? I've taken you through the entire matrix of the problem. Now it's your turn. Do you think the universe needs consciousness to know it exists, or does consciousness need the universe to understand itself? You answer. I'll sit here, smiling like an old physicist, and listen. If you enjoyed this journey of discovery, remember to subscribe to the channel so you don't miss the next science stories. See you in the next adventure, where the universe continues to whisper new secrets.